So in this video, we're going to find a particular solution for a first order linear differential equation. So it says solve this differential equation when y of 0 equals 1. So we're going to be looking for a particular solution because we've been given an initial condition. We're going to be able to solve for the constant of integration that we wind up with, which is going to be what makes this a particular solution. Remember, a first order linear differential equation has the form a function of x, or a of x times y prime plus some function of x times y equals some function of x. And so we have a function of that form. The constant 2 is a function of x, 6x is a function of x, and our c of x term right here is just a function of x. So it is a linear, first order linear differential equation. So first step is to just rewrite your differential equation. So 2y prime plus 6xy equals x e to the x squared over 2. And then what we want to remember is that if we have a first order linear differential equation, we want to get a leading coefficient of 1 on the y prime term. So we're trying to put it in the form y prime plus p of xy equals q of x. So first step here would be to divide both sides by 2 or multiply through by a half. So a half of 2 is 1, a half of 6 is 3, and we get 1/2 x e to the x squared over 2. And then that's going to tell us that our p of x term is equal to 3 times x. And then we need to find our integrating factor. So our integrating factor is always going to be of the form u equals e to the antiderivative of p of x dx. So in this case, u is going to equal e to the antiderivative of 3x dx. And if we integrate 3x dx, we get we're going to get e to the 3/2 x squared. So that's going to be our integrating factor. Next step is to multiply both sides by the integrating factor. So we multiply the left hand side by the integrating factor e to the 3/2 x squared, and we multiply the right hand side by the integrating factor e to the 3/2 x squared. So on the left hand side, I can just distribute this in. I'm going to wind up with e to the 3/2 x squared times y prime plus e to the 3/2 x squared times 3xy. And on this side, I'm going to have 1/2 x, and I have the same base, which means I just add the exponents. I already have a common denominator of 2, so it's going to be x squared plus 3x squared is 4x squared over 2 is just 2x squared. And then the idea is, if we've done our integrating factor correctly, if we haven't made a mistake in the process of putting it in this form and haven't made a mistake with our integration, the result that we have on the left hand side should just be the integrating factor, which is e to the 3/2 x squared. It should be the integrating factor times y prime. It should be the derivative of the product of the integrating factor and y. And on the right hand side, we still have the 1/2 x e to the 2x squared. So the check on work is to take the derivative of this product and make sure you get the previous line back. So e to the 3/2 x squared times y prime is sitting right here. And if I take the derivative of e to the crap, I get e to the crap. There it is. And then the derivative of 3/2 x squared is going to be 3x, which is right there, times the y. So quickly taking the derivative of this verifies that we don't have an error. And now I'm ready to integrate both sides. I'm going to integrate the derivative so that they cancel. And I'm going to do it with respect to x. So this is a dx. So on the left hand side, we're just going to get e. And then plus, because I'm integrating, I'm going to get plus a constant of integration. I could probably wait to the next line to do it, but I think I prefer to do it on this line. So I'm going to get e to the 3/2 x squared because the integration cancels the differentiation for me. And on this side, I'm going to get a half. And then x squared e to the 2x squared. I've got the derivative of So this is going to be a chain rule problem. The derivative of 2x squared is about what I have out here. It just differs by a constant. So I know that e to the crap is going to be my guess on the antiderivative. So I'm going to guess e to the 2x squared. And the idea is when I take the derivative of e to the 2x squared, if I take the derivative of that, I get e to the 2x squared times 4x. And that's not what I have here. I have 1/2 x. So I need to put a tweak factor here so that when this 4x comes down, the 4x simplifies to 1/2 of x. So I'm going to multiply by 1/4 to kill that 4. So I'm going to multiply by 1/4 so that that 4 dies, and I've already got my half sitting right there. So right here I'm going to write 1/8 e to the 2x squared plus my constant of integration. And again, the check on work would be to take the derivative of this and make sure you get 1/2 x e to the 2x squared back. The goal is to solve this for y, to get a y equals kind of thing. But because I have initial conditions and I'm going to be looking for the particular solution, I know that I need to solve for the constant of integration. And the constant of integration is going to be easy to solve for right now. It's going to be actually a little bit more difficult to solve for if I solve for y first. So what I like to do when I see that I've got c kind of hanging out by himself and I know I need to solve for him, I like to just go ahead and get that over with early rather than later. So instead of solving for y first, I'm going to go ahead and find my constant right here of integration. So I'm going to plug my 0 in for x and my 1 in for my y's. So if I step over here and do that, I'm going to get e to the 3/2 of 0 squared because x is equal to 0 right here. And then it's going to be times 1 because y is 1 when x is 0. Right, they're giving us an ordered pair right there. And this is going to be equal to, and right here I have an 1/8 of, it's going to be e to the 2x squared when x is 0. And then it's going to be plus that constant of integration. So it simplifies pretty nicely. We wind up with e to the 0 as 1. 1 times 1 is 1 plus, and then x to the 0 is 1. Now, why do I have an x there? That's an e. Oh my word. E to the 2 times x squared. I don't know why I wrote an x other than droning out like a frybaby. So e to the 0 is 1, and then we get 1/8 times 1 is 1/8 plus a constant of integration. Subtract that 1/8 from both sides, we get 7/8 is our value of c. So now I know what c is. I'm going to go ahead and move to the next step. So if I replace c with 7/8, I already have a denominator of 8 here. So I'm going to have on the right hand side a common denominator of 8, and I'm going to have e to the 2x squared, e to the 2x squared plus the 7 in the numerator position. And over here I have e to the 3/2 x squared times y. Now I'm ready to solve for y. And I could divide both sides by e to the 3/2 x squared. That would be one way to do this. The other way to do it would be to multiply by e to the negative 3/2 x squared. And I found doing it this way when you're working with differential equations, there are a lot of cases where your life will turn out to be a little bit better if you do that. So e to the negative 3/2 x squared. So we get same base, so we add exponents, but when we add these two, we get 0. E to the 0 is 1. 1 times y is just y equals, and then I can distribute this e to the negative 3/2 x squared into the parentheses. And if I do that, I'm going to get the same base, so I'll need to add the exponents. So 2 is the same as 4 over 2, so that I have a common denominator on for my exponents base e. So I'm going to have my 8 in the denominator. I'm going to have e times e. I'm going to get an e with the sum of the exponents. But 4/2 x squared plus negative 3/2 x squared is just going to be x squared over 2 plus a 7 times the e to the negative 3/2 x squared. And that is the particular solution for the given differential equation.